We are talking about scientific notation, and we want to use properties of rational exponents to simplify expressions with rational exponents. So here we want to write each number in scientific notation. So whenever we get to scientific notation, we always want to make sure that we only have the ones place showing. So we want to have the decimal so that we only have one showing in our solution. Then we're going to show all of the numbers that trail the zero or trail the decimal except for the zeros. So we just have one. Then we're going to say times 10. So that 10 tells us that we're just going to move the decimal point. And in this case, the original decimal point is over here, and we are going to move it 1, 2, 3, 4. So we are moving it to the left, a positive 4. So if our number is getting smaller, so this is 61,000, 61,000 is going to 6.1. So if we're shrinking that number, in order for this number to get back to that very large number, we have to raise it to a positive 4. Here we have 0.04. So again, we want to have our decimal in the ones place. So we want to move it to here. So that is going to be 4. And there's no numbers that trail the decimal. So there's nothing there. So we don't have to write anything else there. We're still going to have times 10. And then we have to figure out what our exponent's going to be. 4 is larger than 0.4. So we're going to move the decimal point 1 unit. So we're going to the right, and that's going to be -1. So we're moving to the right. So 4 is larger than 0.4. So in order for 4 to become 0.4, we have to multiply by 10 to the -1. If we look at number 3, again, we want to put the decimal so that only the lead term is in the ones place. So we have 9.6. And then we're still going to have times 10. And then we got to figure out what our decimal point is. Now, 9.6 is a lot larger than 0.000096. So we know that it's going to be negative. So how far do we have to move the decimal point? We have to move it 1, 2, 3, 4, 5. So that is going to be to the -5th. 5 this way means -5. So that's in scientific notation. Here we have 62,500. And in that case, we still want to have the decimal so that only a one place is showing in scientific notation. And then we use all of the numbers after the decimal except for the zeros. So we want to go 0.25. We're still going to have times 10. And then we have to decide 6.25 is a lot smaller than 62,500. So we know that we're going to have positive. So we're going to move it to the left, and we know that it's going to be a positive value that we put in our exponent. So 1, 2, 3, 4. So that's going to be positive 4 or 10 to the 4th. Here we have 8.6, and we want to write that in scientific notation. Well, in this case, we have the decimal point is already in the correct location, so that's just going to be 8.6. And we didn't move it. We didn't move it to the right. We didn't move it to the left. So that is going to be times 10 to the 0 power. And remember, anything to the 0 power is equal to 1. So this just says 8.6 times 1, which remains 8.6. Number 6, we have 0.000059, and so we want the decimal point to be here, so it's going to be 5.9, and then we still have times 10, and 5.9 is a lot larger than this decimal point up here, so we're going to move that decimal to the right, and then we know that that's going to be negative, so we're going to move 1, 2, 3, 4, 5. So that's going to be -5. So that's 5.9 times 10 to the negative fifth.